Earth Systems 3209, Unit 4, The Forces Within Earth. References for this unit can be found in Chapters 4, 15, 16, 19, and Appendix A and Appendix B from the Curriculum Guide. Unit 4, Topic 4.1. This topic will look at the terminology associated with seismic activity. This presentation will focus on defining the following terms: seismology, earthquake, seismic wave, foreshock, aftershock, seismograph, seismogram, focus, and epicenter. When we look at the terminology associated with earthquakes, an earthquake occurs when the elastic energy is released and sends out vibrations that travel throughout the Earth. These vibrations are called seismic waves. And the study of how seismic waves behave within Earth is a science called seismology. The focus of seismology centers around the study of seismic waves, and seismic waves are given off by earthquakes. By definition, an earthquake is the vibration of Earth produced by the sudden, rapid release of energy. And this release of energy usually occurs along faults. The main causes of earthquakes may include, number 1, the movement of magma, which is evident at divergent plate boundaries. Number 2, the elastic rebound theory, which focuses on the release of elastic stored energy along faults. And number 3, the movement along faults. In general, these faults are mostly transform faults that display some of the most prominent earthquakes around the world. Let's first look at the two terms, foreshock and aftershock. A foreshock is a minor earthquake preceding a greater one, which may originate at or near the same location. So foreshocks can give you a warning of an earthquake that may happen sometime in the future. An aftershock is a small earthquake or tremor that follows a major earthquake. And these are common where we have prominent earthquakes that range on Richter's magnitude scale anywhere greater than 5. Aftershocks generally are set off by little minor movements along the fault after the main earthquake. Let's look at another two seismic terms. These are earthquake focus and earthquake epicenter. When we look at a fault is the plane or zone of fracture separating two blocks of Earth that are abruptly displaced during an earthquake. If you look at the diagram to the right, we can see the fault or the fault plane that's indicated by the solid line going down at an angle. And this is the plane in which you see movement of the two earth blocks on the left and the right. The focus of an earthquake is the point at a depth, usually in the fault zone, where the displacement and sudden release of elastic energy originates. So the key point here is the focus of an earthquake is the point where the energy originates. It is marked by the initial release of energy associated with the earthquake. And the epicenter of an earthquake is the point on the surface of the Earth that is directly above the focus. It should be noted here that the point of origin, which we call the focus, cannot be pinpointed by a seismologist. The only point that can be determined is the point directly above the focus, which is called the epicenter. So when scientists determine the location of an earthquake, they pinpoint the epicenter of the earthquake, and they cannot determine the depth below the Earth where the actual earthquake originated. They can only pinpoint the point on the surface of the Earth that is directly above where the earthquake originated. And that point of origination is called the focus. Let's look at two terms that are used with seismic activity, and it looks at the instrument that records seismic activity. The instrument that records seismic activity is called a seismograph, and the seismograph itself produces a paper record called a seismogram. So earthquakes generate seismic waves, which can be detected with a sensitive instrument called a seismograph. How a seismograph works is as follows. We have a free weight that is freely suspended from a support, usually a spring, that is attached to the bedrock. When the earthquake occurs, inertia keeps the weight motionless, while the rock and the supports will vibrate. If we look at the diagram to the right, we see a light blue line that passes in a horizontal pattern through all three weights in the three diagrams. The first diagram represents the weight that is suspended from a spring when the earth is pretty well motionless. After an earthquake, the earth will vibrate in an up and down motion. This up and down motion will take the earth upwards, and as a result, the free weight, which is suspended on a spring, will stay at the same point at which it originated. That's due to inertia. An object at rest will tend to stay at rest. Therefore, the green weight stays at rest, while the earth moves up towards it. In the down part of the vibration, the earth will move back down, while the spring contracts, and the spring, or the weight again, will remain motionless because of inertia. This up and down motion of the earth, while keeping the weight motionless, is the principle that's used behind a seismograph. In the diagram down below, we see that a pen is attached to the green weight, and a roll of paper would be attached to the earth. So as the earth moves up and down, the paper would move up and then down, and the vibration will continue to cause the roll of paper to move up and down, while the weight itself stayed motionless. This weight, with a pen attached, would leave markings on the paper as it rolled off, and it would leave a trace of the pen which shows the vibration of the earth and the magnitude of the vibration of the earth. And this paper record is what we call a seismogram. So again, a seismogram is the graph output by a seismograph, which was previously described on the last slide. It is a record of the ground motion at a measuring station. We use the seismogram to locate the epicenter of the earthquake. And these paper records are important when seismologists want to locate the position of the epicenter of the earthquake. What's recorded on a seismogram are the different types of seismic waves. These include P waves, S waves, and surface waves, are all recorded on the seismogram as the paper moves up and down with the motion of the earth. An example of a seismogram is seen below. We see the initial vibration of the earth before an earthquake, where the vertical motion is very little. But where the seismograph is a very sensitive instrument, we do see a little bit of motion up and down as the seismograph tends to move with the motion of the earth. With the onset of an earthquake, we get the first initial kick, where the vibrations of the earth moves the seismograph up and down. The arrival of the primary wave would initiate the first initial kick. Then we have a little resting stage where the secondary waves would arrive, and you get a bigger motion in the earth. And then finally, the third wave that arrives, and is much slower than the primary and the secondary wave, is the surface waves. And these surface waves are the waves that cause most of the destruction during an earthquake. These cause the seismograph and the earth to move with great motion. So a seismogram will show three different vibrations recorded on the paper as the seismogram and paper move up and down in a vertical direction, whereby the weight with the pen remains motionless. The primary wave is the first to arrive at the seismograph station, followed by a secondary wave, and followed by your surface waves, which cause most of the destruction. Let's look at some examples of past public exam questions. First question reads, which branch of earth sciences would study the properties of earthquake waves? Earthquake waves are called seismic waves. Therefore, the answer to this question would be C, seismology. Example number 2. Example number 2 reads, in the diagram below, where is the epicenter of the earthquake located? So if we refer to the diagram below, we see there are 4 points that are listed on the diagram. Point A will be located right at the top of the fault. Point B, located on the surface of the earth, and also point C, which is located on the surface of the earth. And finally, point D, which is located below the fault. The line that moves down at an angle is the fault line. And this is, somewhere along this line, will be the position where the earthquake would originate. And the focus of the earthquake is the point of origin of the earthquake. And we see here the little circles that move outward from the focus will be the energy that is released once slippage occurs along the focus, at the focus along the fault line. So the epicenter would be the position directly above the focus of an earthquake, and therefore the answer to this question will be position B. The epicenter of this earthquake is located directly above the focus of the earthquake, which is at position B. So your answer would be B. Your turn. Take the time to complete the following questions. You can pause your recording now to prepare your answers, and solutions will follow on the next slide. Questions read, which of the following instruments can help locate how far away an earthquake occurred? So if we look at the answers below, we see magnometer, which measures magnetism, a tilt meter, which is a meter, I guess, that can measure the tilt of something, but it's a distractor in this case. And then we have seismograph and seismogram. So one of those 2 answers will be your best answers, where seismo refers to earthquake energy. A seismograph is the instrument which records earthquake waves or seismic waves, and a seismogram will be the paper record that is produced by a seismograph. So the instrument that records how far away an earthquake occurred would be your seismograph. The seismograph is the instrument that would record the motion on the earth. So the answer to this question is A. Second question reads, which is the point of origin of the earthquake? Again, when we look at a previous slide, we saw that on the diagram, the point of origin of an earthquake would be its focus. And the point directly above the focus on the surface would be the epicenter, and the focus of an earthquake would occur along a fault. So the answer to this question would be D, focus. So when we review the questions, question number 1, a seismograph is used to record the location of how far an earthquake is away, and the focus is the point of origin of an earthquake. In summary, some of the common terminology used when you study seismology include seismology, which is the study of earthquake waves, in particular seismic waves. Earthquake, which is a rapid release of energy within the earth. A seismograph is the instrument used to record earthquake or seismic activity. The seismogram is a paper record of the movement of the earth, which is generally seen as primary waves, secondary waves, and surface waves on the paper record. The focus, which is the point of origin of an earthquake. Epicenter would be the position on the Earth's surface directly above the focus. And it's important to note here that scientists cannot determine the exact location of the focus, but just a position above the focus, which we call the epicenter. Foreshock, which are small earthquake waves that precede a major earthquake, and aftershock will be the earthquake waves or tremors that occur after a major earthquake. So these are the 8 terminologies that are commonly associated when you look at seismic activity.